Just a heads up, guys, the audio for this video got completely ruined when I recorded it. I tried a new setting for OBS, which completely crackled the crap out of it. I did the best I could to repair it, but it's still pretty terrible. I thought about just canceling the whole series over it, but, I decided to just go ahead and release it as is. Again, I apologize. I'm never using that setting again, and future videos won't have this problem.
This is going to be a new series. I'm trying some new audio settings. I'm hoping they all go well. So I wanted to put together a programming series, a game programming series, a smaller one than normal. But I wanted to do something that utilized a genre that I feel like has died out since it was really popular in the 90s and in the late 90s, early 2000s, and even a little bit in the 80s, and that's point-and-click adventure games. Some of the first NES games I played were, some of my favorite ones were adventure games. I used to love the idea of trying to figure out what items to use or which paths to take, and seeing all the things that can go wrong was super fun for me. And even some of the later generation adventure games, when they started becoming more graphically advanced for the time, those were great. And I think it's kind of a shame that everything's gone the direction of, I kind of call it genre unification for games. Everything's becoming a first-person feel, and it's almost like you can't play a game nowadays without it feeling like the same genre. So I kind of wanted to make this series because I wanted to encourage game developers to, explore some of the forgotten genres and just get more creative. I mean, I think it's really cool being able to use, parts of your imagination to kind of fill in the gaps that, might be spoon-fed to you when you're running on a modern game engine. And it's just something that's kind of near and dear to me. So, and the text, these games started as text adventures before they were graphical. Text adventures were a little before my time. And those text adventures and the text descriptions of what you're seeing when you're playing these games, they really help kind of paint the mood, almost like you're reading a book. So what I've done is I've kind of laid out a very simple template for how we're going to do this. I did not put as part of the series the asset generation, the images. I've pre-created the artwork for the game so we could focus just on the programming. It's really important to say the artwork doesn't matter here. I can't stress that enough. When I first did this when I was like 16 years old in Visual Basic, I made an adventure game and I drew all the pictures using MS Paint. And they looked like crap, but it was still really fun to make. And my friends played it and they thought it was funny. So don't worry about how you come up with the artwork. Draw it in Paint, or whatever, Photoshop if you want. I went ahead and rendered my images out for our simple mini game just using some 3D, really simple 3D environment that I put together in Blender. And what I did was I generated the terrain in Verto Studio on the Mac, and some of the assets I imported into Verto. And then when I was done, because Verto doesn't ray trace yet, I exported those into Blender and then added multiple cameras in Blender. And then I would render the scene from various vantage points that I knew, would be nice kind of waypoints to stop. But it's important for me to say that this 3D environment, there is no 3D OpenGL, there's no 3D at all in the game we're going to make. We're only using the output of this. I hope I saved that. We're only using the output of Blender, which is these rendered images. And so there's that. And I also rendered out some really terrible cursors. I'm doing this in the art style of early 2000s, late 90s, back when everything was kind of pre-rendered and the 3D had this very, now it's almost retro look to it, and I wanted to stick with that. So all the cursors that I have are all very similar to that stuff. So I got the images ready. I'm going to use the same font that I used for my very first series. I got the Xcode project set up. In the usual fashion of my YouTube series tutorials and programming, at the end I will provide the code. I may provide the code in the intermediate steps of the video. I'm not sure if I'm going to do that yet. This will look like Greek to you if you've never written a line of code in C and C++ in your life. So if that's the case and you're coming into this video I'm not going to explain that stuff simply because I have 2 other series on learning C and then learning C++. So if you don't know C++, I recommend you check those series out first before going into this. This is strictly just how to program this if you have a base understanding in C++. So here's what we have right now. If I were to run this, all it is a blue, it's a 720p window that pops up with a blue screen. That's it. So what I've done was I based this off of the Espresso C C++ game loop template, but I pulled it out into separate header files, CPP files. In other words, I properly modularized it so it's not all sitting in one file. So we're going to be doing a lot of our work in the game loop class, and more specifically probably in the game loop render method, do render method, update logic, and then process, what I call that, events, which is our input processor. So that's where most of our work that we're going to be doing in this game is going to live in. As we advance, we're going to start making some classes so that we can keep this organized in an object-oriented fashion. And yeah, that's how we're going to do it. And if you want to look and see what the int main is for this, it's very simple. All I do is run some Mac-specific setup. It's not even worth mentioning. Create an instance of the game loop object using a smart pointer, a C++11 smart pointer, run the game, and then when the game quits, everything just goes down. Just the destructor of our game loop class will run, and this is where we will destroy all the assets. So what we're going to do today, we're just going to do a very brief, basic kind of getting our feet wet for this kind of programming, because this is unlike any kind of side-scroller programming we might have done in the past in this channel. We're just going to create very basic framework for how we expect this game to work, and we might get like a single scene, like a single image on the screen, and we'll create the class for that, and then we'll draw the we'll get the mouse cursor working. So I'd like to do the mouse cursor first, simply because hopefully it'll be the simplest. Famous last words. So what I'd like to do is, first things first, I want to create an STL texture for the mouse. Now the mouse is going to have multiple cursor states based off of the way this game is going to work. You're going to hover over certain regions within the scene, and those regions are going to define whether or not you can click on those regions. For example, if you want to go forward, left, right, up, down, or back. This is a very simple series, so we might not utilize all those cases, but it would make sense to at least program the ability for us to do that if I wanted to turn this to a full-fledged game. So just thinking out loud right now, I think the way I'm going to do that is I'm not going to bother with a mouse cursor class. I'm probably just going to go ahead and declare the STL textures for the mouse cursors right here inside the game loop. And what I'm going to call this is basically mouse cursor. And this guy will be the pointer that we're going to set equal to the current active mouse cursor. And then we're going to have an array of these guys, which will basically be the all the cursors, and we'll just pick the pointer to point to whichever cursor is active based off the current setup. So if I were to look at my images here and count how many cursors I have up, down, left, right, normal, forward, back. So 1, 2, 3, 4, 5, 6, 7, 8. So there's 8, unless I counted that wrong. And we're going to load those right inside our constructor, which will kind of serve as our init. You'll also notice here I added a call to tell STL not to show the operating system cursor, because it'll render on top of our game cursor and it'll look really stupid. We don't want our game to look stupid, do we? So real quick, I'm just going to declare an array of these names. Hold on. I'm being a little fancy here because I don't like to do a lot of unnecessary typing these days. So I'm going to create an array of cursor names, which are our file names, and we're going to set that equal to, son of a bitch, I guess I'm going to have to do work. Why I always have to do work? Games should just be like, click one button and the game's done. I'm just kidding. But I am really lazy, like, nowadays at this kind of stuff. Like, if this was more than like 5 things, I would do a text wrangler, like search and replace, because I don't like repetitive tasks. I'm going on a tangent. Okay, so those are our names, and what we're going to do here is, what did I say, 8? Seems like there's 8. 1, 2. Yeah, we're gonna iterate through here, and we're gonna load these in turn. And I guess it wouldn't hurt to put some comment here and just say load mouse cursors. This is basically the first thing we're going to load in our game. You could probably guess how this will look if you've done this stuff and looked at the other videos. I basically set this equal to STL create texture from... It's been a while since I've done this, so I got to remember. I'm pretty sure I have to do this from surfaces, and there's no shortcut to load a texture directly into a file name directly into a texture. So what I'm going to go ahead and do here is load the surfaces as temporary variables inside our for loop. And we're going to use our handy, I've already included it somewhere. I think I included it in main.h STL image. And I'm going to use image load, which will load our various cursor names one at a time. So that'll give us our surface. If we don't have a surface, all hell will break loose, and we probably should report that and not let the app crash. So I'm just going to include standard exception here so we can throw a runtime error if things go wrong. And I also don't like typing standard double colon everywhere, so I'm going to use namespace std. So if we can't find the surface, we throw a runtime error. Oh shit, fuck, we're all dead. That's a pretty good error for someone to see if something goes wrong. And now we have our surface. We use that surface. Why is this thing complaining? Oh, this is mouse cursors, not cursor. And then once we get our texture, we destroy our temporary. We don't need to load, we don't need to keep the surfaces around as usual. We only need to keep the textures around. And I'm going to set the default mouse cursor equal to the normal cursor, which I hate to do a lot of upfront work in our project, but it would make a lot of sense to define these out, or define these out maybe with integers. Again, if we ever did make a mouse cursor class, it's good to clump all this stuff together so we know what's what. But what I'd like to do at this point is have symbolic constants instead of hard coding magic numbers in here, so that we are not, so we can keep ourselves organized. That's the name of the game when you're That's the name of the game when you're programming a game, is to keep things as organized as possible so that you don't get drowned in complexity. So let's just make all these. That's 8, because it goes to 7, but 0 counts. So I did that right, I think. Probably find out later that I screwed something up. I kind of wouldn't mind having these all be on one line, but in the sake of time, I'm going to leave it like this. So now this lets us program in a more symbolic way. Humans are inherently used to seeing symbols and not numbers, so if you can make your programming easier by using symbols, it makes much more sense. So now we can say mouse cursor equals mouse cursors, cursor normal. And that is great. Now we can use this texture, and whatever texture we set it to render the mouse cursor every single frame. So really all we need to do now is use STL render copy to render our mouse cursor at the current. If you pass an all for both of these, you get the full thing, as I've said in other videos. I just want to quickly, oops, that was retarded. Hold on. STL rect dash cursor rect. Our cursor is 64 by 64. I'm going to draw it in the lower left or upper some corner. I get my corners confused between OpenGL and STL. I want to draw it in the corner so that first, before I make it actually follow the mouse, because I just want to walk before I can run here. Can I go up there? Okay. So let's see if we see anything here. There's the cursor. Wow, 32 by 32 might be too big, but we always have the option of using software scaling to scale it down. I don't recommend doing that in production games because it wastes memory, but it helps you rapidly work on the game instead of having to every 5 seconds go back into Photoshop and adjust your assets. You can always manually scale them down when the game's done. So that worked. So now we want to do is STL get mouse something. I don't have all this API memorized. I think this is what I want. So I think I want to declare 2 ints, and I want to pass those by reference. This is C reference. Remember, STL is a C API, so you can't use C++ tricks like reference parameters when you're using it. Now this thing has a return value, and if I were to guess, it probably would return if it failed, and it would be smart to maybe make sure it didn't fail, so we're not using uninitialized variables for X and Y. Return value. Oh, well, I guess it can't fail is basically what it's telling me. So I think we're good to leave these uninitialized and just assume they will be filled in and it will succeed. So I'm going to go ahead and pass this directly in to our cursor rect, which defines the position of our cursor rendered. And once I draw this, we should have, there it is. I kind of like the cursor being giant. It reminds me of how tacky some of the late 90s games were. The important thing, though, is that the cursor is rendering properly such that the actual tip of the sword is where you're clicking, and that will change based off of which cursor we use. For now, I'm not going to worry about that, but it looks like we're actually doing it right here. So, but yeah, that's just something to think about when you're doing mouse programming for the first time. So now we're going to create a class for our scenes, and basically what our scene will define is one screen of our adventure game. So if you're in a certain state and you're looking at something, it's one scene. If you click to go somewhere else, then you transition to another scene. That's kind of how I'm going to structure this. So I'm going to create a class called scene, and we are going to call it scene public private. I'm not going to use inheritance, or I would put protected down there. And the basic gist is the scene will have some arguments to define what it is, and it'll have some private stuff in here. Let me include main.h, which includes STL for me. Yes, we will have the background, or I don't even know if I want to call it background. It's really just the image which defines the entire scene. And what we'd like to do here, there's a couple things I could do. I could pass the entire scene in by name, but what I'm noticing that I did with my naming of my files here is I basically already have numbers. So what I'm thinking of doing is maybe passing in just a number, and then maybe like a B or an A for like alternate cases where like this door can open. So what I'm probably going to do is just say scene ID, which will be a number as an argument when you're creating one of these. And then alternate, which will default to being 0. 0 will be nothing, 1 will be B, C, and so forth. And if there are any items that need to be loaded in, for example, this key, which I overlay on top, I rendered this using Blender layers. Again, please don't worry about the artwork. You could draw this in Paint. It's not that big of a deal. I would say, though, if you're going to have items in your game that you can pick up, you should render those on a separate layer. I'm going to get into that later when I talk about the items section, or the items version of this series. But again, yeah, they should be on their own layer so that they have an alpha transparent background. And these are all ping files. So in the case of items, what I'm thinking of doing here is just passing in a vector array of these items, and these items will basically be well, actually, I don't even need to do that. I probably could just number of items, right? So num items, and again, that's 0. And if there's more than 0, I can just iterate through obj1, obj2, obj3. I'm just trying to be kind of smart with the way I want to save myself work. Even though I don't plan on making this into like a 10-hour or 40-hour adventure game, it's smart when you're programming, if you want to learn, to program as if you would, and to always keep yourself as organized as possible. So to make it so that if you're a year into this and you're exhausted and you're like, I really want to finish my game, you would wish that you made it easier on yourself in the beginning. And that's kind of the idea here. That was a lot of talking. So there's scene. I think so there will be something that we're going to want to do. It's going to come much later, and it's going to involve a string, and that string is basically going to be the description. And this is going to be, actually, I like the word narrative better. This is going to be the text that animates and kind of paints the picture of the current scene for the person playing. Very important. And I'd like to have that narrative come in separately, so I'm probably going to create a setter for that and just call set narrative. Pass in the standard reference parameter, passing of the string, and the way this method will exist is basically it'll just set the narrative. This is an example of C++ encapsulation if you guys are curious. So what I'm going to quickly do here is go into the CPP and start implementing some of these things for us. Again, I freaking hate Xcode for not having an automation tool for doing this for me from a header file, but you know, whatever, because it's already done. Another thing I'd like to have is a method for rendering the scene, and really what this is going to do is draw almost a significant portion of the game screen for us, maybe even the whole thing. I'm just kind of planning ahead here. And there's a very good chance that that is going to need a copy of the STL renderer, because you need a copy of that, or a reference or a pointer to that, to do just about any rendering in STL. So we're going to give that as an argument. So everything build, everything does. We're good. Everything's just fine over here. Don't you mind me? Okay. Well, I could guess that what we're going to want to do is synthesize a string, or construct a string that contains the scene that we want to load based off of our integer arguments. I'm not going to load the items in yet. I'm going to leave that part out, but I will handle the alternates. There also, yeah, I already have my texture in here. So what I'd like to have is a string, again, namespace. I'd like to have a string, which is going to be the file name for our image, and that's going to always have a base name of scene. So we're just going to set it equal to that. Now, I quickly realized you can do tricks with the C++ string class, like basic adding two strings together, which splices them or concatenates them, which is a fancy word for just joining them together. But if you want to mix numbers into the game, you got to use string streams, which are a way for you to build strings the same way you might use C++'s IOStream to see out things. If you've never messed with IOStreams and streams before, they're really not that big of a deal. I don't want to go too much into them. I'm just going to kind of give you guys a brief example of how this might look, and then you'll just see it in action. So we've created a file name stream, and then what I do is I insert into that our base name of scene, and then I insert into that the scene ID, which would change this to scene 1. And then if there's any alternates in there, I got that was stupid. If there's any alternates in there, this is a shortcut for if alternate is not equal to 0, which means 1, 2, 3, whatever. And the default argument is 0, if you remember. Now this is kind of me being dumb. I put B in here, but the number is going to be 1. So I'm going to kind of do a really stupid cheat where I'm basically going to create a character here, and I'm going to set this equal to B, and I'm going to add to it the alternate. Actually, I'm going to set this equal to A and add to it the alternate. And what this will do for me is essentially add the ASCII value, add to the ASCII value of A, the alternate. Now, I'm not going to trust myself with this. I'm going to use, oh God, I didn't mean to open this. I'm going to use Espresso C, which is kind of my Swiss Army knife programmer's calculator, to make sure that it's really going to do what I expect it to do, so it doesn't like create the wrong character. So I'm just going to really quickly, briefly create something called alternate and set it equal to 1, and then I'm going to see out the result of this and make sure that this is going to do what I say it's going to do. Otherwise, we're going to be screwed. It does, and I bet if I change this to 2, I'd get C. So it's pretty intuitive dealing with you know, adding things to ASCII. So we've confirmed that that's going to do what I wanted to do. So at this point, you could probably guess it's as simple as me just adding an underscore, adding an underscore, and then the character that we just added directly into the stream. So basically this, and then our alternate, And then we've inserted that. And again, this only happens if alternate isn't 0. So we're not going to end up with an A in here. I'm only doing this to make it match with the pattern that my assets are. This is a useful skill. I know it seems stupid. You're probably like, why didn't you just do scene 7_1 or 2? As a programmer, it's a good exercise to assume that the person doing the artwork and the person being the programmer are not the same people. And your artist might say, well, I made all these, and this is the format, and these are the file names. And there might be thousands of these. So as a programmer, it really doesn't hurt to be as versatile as possible when dealing with stuff like this. So it's a good example. So we have scene, maybe _B, and then we need the final part, which is the extension, .ping. And now we've created it. So now you can convert the string stream file name to a regular string by just calling .string on it, or .str, with no arguments. And what this does is gives you the file name. I'm going to use it inline here. So in other words, bear with me, this is going to look a little nuts. I'm basically going to create our STL surface, set this equal to imgload, and then we're going to use file name, convert it to a C++ string, and then convert it to a C string, because again, SDL is a C API. It doesn't know anything about C++ strings, so we convert this to a const char, which is a C string, a const char pointer. And again, you don't have to worry about the memory managed by this. It all still lives inside the string stream. So that creates the STL surface. If the surface doesn't load, it would not hurt for us to throw a fatal exception so that we can know that happened. So if there's no surface, again, if not surf is shortcut for testing if surf is null. And we throw the runtime error, all is lost. But that won't happen to us. You know, we're better than that. And now we can take our image texture and set it equal to STL create texture from surface. Son of a bitch, this needs a renderer argument. I always forget about that. So let's give it the renderer. If you ever have to go back, you know, just get it out of the way. Make sure you update the header file as well. Okay, damn it. Renderer and then surface. Again, do not forget to free the surface that you use to generate the texture, because if you don't, you will be leaking the memory, and that's just bad. And again, same deal goes with the destructor. When the scene goes down, we destroy the texture, because that's good cleanup practice as well. Our narrative setter is really just me setting narrative equal to the string argument. Again, this is passed by reference. It's just good practice so that we're not copying the string when we pass it as an argument into this function. But of course here it does get copied. Finally, we can render the bloody scene. This function will get way more, well, reasonably more complex as we go through the series. Right now, all I'm going to do is render the texture. You'll happen to notice the texture is exactly 720p, so it matches the window perfectly, which means all I have to do here, is pass the image in and then two nulls here. I tend to use uppercase null when I'm working with C APIs, and null pointer, which is the C++ 11 type for null, when I'm working with C++ types. It's just nitpick, it doesn't matter. So that's our scene class. It's super simple right now, but like I said, as we go, it'll get more advanced. But I like it because now we can immediately use it inside game loops. So what we can do here is we can include memory here, and we could have a C++ 11 smart pointer to the current scene living inside the data area of our game loop class, or its members, its properties. Properties is a bad word, but yeah, we can include scene here, and we can have a smart pointer to it at all times available as the current scene. And the idea here is that as we load new scenes, we will set this equal to them, and then the old scenes will automatically be deallocated for us, because that's the way smart pointers work. Down the road, when I code up fancy transitions for us, like crossfading between scenes, two scenes will exist at the same time. So it's really smart to have everything living in a scene class, because then you can keep all that stuff separate. So as soon as the game starts, I'm going to load into the initial scene, but I'd like to have a utility method in here and I'd like to just call this load scene. And I don't know how I want to do this. Maybe I would just have the same arguments that I would just forward along to the scene constructor. So I guess that's how I'm going to do this right now. I might change this later, but this is how I'm going to do it. And then once we start our app or our game, we will load scene. We will load the first one, and that's all that matters. The other arguments can default out because there are no alternates and there are no items. And then we're going to define. Notice I'm able to call my function here before I wrote what it was. That's a common way for a programmer not to lose their train of thought. But of course, if I wanted to compile this, I would get a linker error because I didn't made this function yet. This is an annoying part of Xcode not doing what it should here. So let me just copy these guys in. I don't know if I covered this in the C++ series, but if you have default arguments for a C++ method, you're allowed to have them in the header, but in the C++, because it's redundant, you can't have them, so you just take them out. But they're still there. So I think all we have to do now is set our scene equal to C++ shared pointer constructor call for scene, and pass our arguments directly along, and everything, if I did everything right, should just work. So this creates one instance of the scene. When the program starts, I load the first scene, which gets us started, and then when it comes time to render, after the cursor but before the present, I call scene render. And the reason why it's important to do that after the mouse cursor is, before the mouse cursor, is that if I render the scene, then I get to render the mouse cursor on top of the scene. If I render the mouse cursor and then plaster the whole screen with the freaking background, then the mouse cursor gets covered up. So that's how layering works. We do not need to clear the screen anymore. It's more efficient now since we're covering the entire screen with an image to not bother. So I'm going to comment out that stuff. And we're going to run this and it'll probably freaking crash. Oh, hold on. The hell is this? No matching construct. If you ever get an error like this is part of like what I call template hell. I've done C++ long enough to know that when I see this, it means that I got the arguments wrong to the constructor. Don't panic if you see something like this. What you do is you go back and you make sure that you called your constructor properly. And what this thing was complaining about was indeed the scene constructor call, I believe. Yes. So what I have to do here, it's a little bit annoying, but is double check these. So scene has 4 arguments, not 3. First one was the renderer, and that'll fix that error. And then we run it, and our adventure game is already starting to look pretty cool. It looks, exactly the style that I would want. So next time I will teach you guys how to do clicking to transition between scenes, which is pretty involved because it deals with hotspot regions where you can click, where you should click, changing the mouse cursor, all that fancy stuff. But not bad for like a half-hour work. So that's the first video. Stay tuned for what comes next. Goodbye.